Here we have the extra review sheet from the assignment of the day before the test. Everything in black is going to be what the worksheet gives us. Everything in color will be the work that we are doing. This video segment will be on page 1, the front side of the worksheet, and the following video segment will be on the back page. Taking a look at number 1, it tells us that the radius is 14, and it tells the tangent segment, which is QR, is 48. We need to realize that those are intersecting at the point of tangency, which means we have a right angle. Next thing we need to do is connect PR. That will give us our right triangle. Always want to look for a family. So in this case, 14 and 48 have a common factor of 2. So I'm going to make this one 7 times 2. I'm going to make this one 24 times 2. And we should realize we have a 7, 24, 25 family. And since we have that, we know this one has to be 25 times 2. So our answer for PR is going to be 50. Let's take a look at number 2. This one, we have two concentric circles. The radii are 15 and 39. We want to find the length of that chord that it gives us. So we need to draw our radii in. Radii of the small one is going to be 15. Radii of the big one is going to be 39. We need to keep in mind here that we will have a right angle right there. Again, at the point of tangency. So, let's look for x right now. Again, look for your family. In this case, we have a common factor. 15 is going to be 5 times 3. 39 is going to be 13 times 3. So we should realize we have a 5, 12, 13 triangle. So x has to be 12 times 3, which is 36. And we also need to be aware that since the right side of the chord is x, the left side of the chord is also going to be x. So our answer is going to be 36 times 2, or 72. Number 3, we have our walk around problem. First step for these is always going to be take the segment that you're looking for and call one of those pieces x. It doesn't really matter which one. In this case, I'm going to call the left side of that x. Now remember that this side from D to that point of tangency should be congruent. Anytime we have two tangent segments coming from the same point, those segments should be congruent. So that part is also going to be x. Now we want to find the top part of AD. It should be the whole thing, which is 20, minus x. Again, we have congruent segments, so this part of AB is also going to be 20 minus x. Now this part is going to be the whole thing again, 28, minus the part we have on the left, which is going to be 20 minus x. And that's going to turn into x plus 8. So right here we have x plus 8. And again, the part of BC is also going to be x plus 8. Now again, we want to do the whole thing, 10, minus the part on top, which is going to be x plus 8. And in this case, it gives us 2 minus x. This side here is 2 minus x, which gives us the other part of DC being 2 minus x. Now all we have to do is take these two things and add them together. So we have x plus 2 minus x. The x's should cancel out. And 2 is going to be the length of CD. We can look at number 4 and number 5. These are our power theorems. Number 4 should just be a chord-chord power theorem. So all we're doing for this is taking one chord, multiplying its two pieces. So I'm going to do 4 times 9 and then the other chord multiplying its two pieces, 6 times x. That gives us 36 equals 6x, and x in this case should be 6. Let's take a look at number 5. This is a secant. Remember, when we're dealing with secants, it's always going to be the external part multiplied by the entire thing. So looking at the top one, 3 is the outside part, x is the entire thing. That should be equal to 4 is the outside part of the bottom one, the entire thing is going to be 10. We need to make sure we're doing 10 and not 6. So 3x will equal 40, and x should equal 40 over 3. And you can just leave it like that.